Okay, so this is the electronic motor lab. So the main purpose of this lab was to determine how changing some variable would affect the speed at which a coil of wire with a current passing through it would spin in the presence of a magnetic field, in other words, a motor. In our specific experiment, we decided to measure the change in the number of rotations made by the coil in a period of 5 seconds, as caused by a number of batteries, and we decided to go with 1.5 volts, 3 volts, and 4.5 volts. The results of which we found that an increase of voltage directly corresponded to an increase in rotations per the time period, and as can be seen by looking at the data that will be shown later on, it was a nearly linearly increase.
As an electric current runs through a wire, the magnetic field based on the moving current generally follows a simple model of the right-hand rule as shown here. In the case of a coil, the magnetic field and current reflect the same rule, but since the current is flowing in a circle instead of a straight line, the magnetic field is going to behave as if there is a bar magnet within the coil. In the situation that we place a magnet directly beneath the coil with moving current within it, the magnetic field produced from that will cause rotation of the wire coil based on the orientation of the magnetic field and current. For this experiment, we simply placed a wire coil resting on top of 2 paper clips that were held upright by clay. The coil was resting in a way that free rotation can occur when the electric current is applied. We then placed magnets underneath the coil, again resting upon the clay, and once electric current was applied, we applied a bit of force to start the rotation of the coil, and observed that it would rotate for an extended amount of time. We then changed the variable of voltage within the system and observed how the amount of rotations would change based on this voltage, recording the interaction with the slow motion feature on an iPhone camera. Errors within this model are based on the possible inaccuracy of manual counting of the rotations, the slow motion technology provided by the iPhone, and the limited knowledge of the system based on unknown current and magnetic field.
For our results on the table and from the experimental design, 1 battery was subtracted from the copper wire apparatus for each trial. In each trial, the voltage of the batteries were 1.5 volts, and the number of magnets used stayed consistent at 12. To count the rotations, we counted each time the copper wire made a full turn, and we found the number of rotations decreased when a battery was subtracted. For the first trial, there were 42 rotations, 29 for trial 2, and 17 for trial 3. We chose a bar graph to show the direct relationship between the number of batteries present in the system and how many times the copper wire rotated. As we can see, when a battery was removed from each trial, the number of rotations also decreased as the number of magnets was constant. As for the scientific reasoning, the magnetic field present in our system reflected the right-hand rule, and the current present through the coil was flowing in a circle. The strength of our magnetic field as well is directly proportional to the current flowing. Therefore, the magnetic field created by our magnets contributed to our current in the system. If this experiment was performed again, we would need to find the amount of current flowing in the system. As well as Ohm's law helped us define the relationship between the voltage, current, and resistance in an electrical circuit, represented by current will equal voltage over resistance. Current is directly proportional to the voltage and inversely proportional to the resistance. Therefore, if the voltages increase, the current will increase as well, provided that the resistance of the current circuit does not change. In our case, the voltage from the batteries was decreased, causing less current and therefore the decreased amount of rotations, as well as neglect and resistance. There were some sources of human error. Some possible sources of human error that may have skewed our data is that only 3 trials were performed due to time constraints. Another reason is that we counted the rotations with our naked eye and did not use any additional equipment. And if we performed this again, a software like Tracker would be helpful in aiding accurately counting the rotations. There was also possibly some delay between when we started our video recordings and when we started counting the actual rotations. And some final improvements that we could use is changing the number of batteries and the time interval to be longer for more additional trials. Thanks for watching.